In this short video, I wanted to explicitly mention diatomic molecules. They came up last week when we started practicing reaction writing, and they come up a lot. They are important, and it's something that we sort of know, but I think we probably need kind of to bring it back up and really make this information kind of solid. So first of all, diatomic molecules are made of two atoms. And we've got a couple of them that appear regularly as diatomic molecules. These are elements that will appear as diatomic molecules. So the first example we see is fluorine, and then all other halogens behave the same way. So if we think of fluorine with all of its electrons and valence electrons, etc., the fluorine atom has 7 valence electrons. The second fluorine is identical with 7 valence electrons. So we put them together in order to complete octet, and we have an F2 molecule, right? They share 2 electrons. They have a single bond between the fluorine atoms. All other halogens will appear the same way. So fluorine as an element is just one symbol, one capital letter, so no, it's just one element. But it always has this little 2 with it. So it's always 2 atoms of fluorine bound together. We have a similar situation with oxygen. So just a quick reminder, we've got oxygen with 8 electrons total, 6 valence, second oxygen with 6 valence electrons. So they come close together and they form 2 bonds. They share 2 or 4 electrons total. They have a double bond. So we always end up with O2. When we say oxygen gas, when we're meaning element oxygen, it always has 2 atoms and it's always a diatomic. Nitrogen is in the same category. We've got 5 valence electrons for nitrogen, 5 more on the second nitrogen. So they will share all of those in order to have a full octet, right? So they have a triple bond, but we always end up with an N2. They're always nitrogen 1, nitrogen 2, so it's always going to be a diatomic molecule. So once again, even though nitrogen is just an element, it always appears as a molecule with 2 atoms. So from our periodic table, we can kind of follow this pattern. We've got hydrogen that's always diatomic, nitrogen, oxygen, fluorine, and the halogens that follow below: chlorine, bromine, and iodine. So here's our hydrogen, and then the other elements are in this corner, so we can remember them pretty easily. They're all on this side of the table. So anytime we have any kind of decomposition reactions, like NH3 breaks into nitrogen and hydrogen, it's always going to be N2 and H2. Or chlorate decomposes into potassium chloride and oxygen. Oxygen is always going to appear as O2. Or sodium oxide rather breaks down into sodium and oxygen. It's going to be sodium and then O2. So just as elements, all of these molecules will appear as diatomic.